Hey folks, today I would like to do something different. The nature of today's video is primarily going to be the report, or rather documentation of the results I have had over the course of the last month. I've been doing some R&D regarding generative AI for artistic workflows within Blender and Krita as well, both three-dimensional and two-dimensional workflows. And I would like to kind of gather my thoughts around it and document them in some way so that it's easier for me to return and rewatch some of the stuff in case I forget or want to reproduce the results in some manner. So to start off, I will try to show the immediate result of the work I have done. So I was thinking about basing my workflow within Blender in such a way that would allow me to generate textures, generate models, and like even potentially some open pose generation that I could reuse for my scenes and such. And the result as of now is an integration of certain add-ons and locally hosting some of the models. Primarily, it's the Tencent's Hunyuan3D model for the mesh generation and some other like basic stable diffusion models for texturing. And I've also tried my hands on Flux for better quality outputs, and Van Vase as well for video generation. I wanted to see how useful the current AI models, generative AI models, are if I were to utilize them for artistic purposes, whether it's in game animation or game assets or video animations and stuff. And let me show you a demo first, and then I will get into the details and how to set everything up as well. So first, let me activate my conda environment with the correct Python packages and stuff. And we will go to here, and let's start ComfyUI. I am gonna go into details what that is and why it's useful. But right now, I just want to start with a quick demo so that it captures the interest. Let's see, let's wait until it starts up. Of course, it is very much dependent on the GPU that you have, and especially how much VRAM the GPU has. And most of these models cannot go away with like 6 gigabytes of VRAM. You would typically need more. And I am currently running everything on 4070 Ti. And the only kind of base model that I can handle effortlessly is Stable Diffusion 1.5. and flux generation takes me more, and of course video generation and such take up to 10 minutes for several seconds. So now that I have all of the Python goodness running in the background, I am going to show I have built 2 workflows within Blender that can interface to the models. Can interface with the models, and let's start with something simple. Let me maybe remove this. If you are unfamiliar with Blender, I don't think I will be able to give an introduction to what is possible. I think it is better if you watch some tutorials and such. But the general idea is that a Blender is an universal 3D editor that allows you to do modeling, texturing, animation, procedural modeling, procedural generation. It has Python, and you can also interface through C++ code with Blender. You can do video editing, you can do 2D animation, which is something I'm gonna get into. And it's an awesome free software overall. And it only made sense that people would come up with ways to connect it to AI interfaces. This is not something that comes in naturally, but it is something that we can install because there are some mad lads that are doing incredible work with writing add-ons and stuff, which is a time-consuming matter. But now that I have connected to the ComfyUI environment, again, we're gonna get into details what that means a bit later. And now I have this simple workflow that would generate a yellow car on white background. I'm using Stable Diffusion 1.5, and I'm going to attempt and run the nodes. Here we can see the process kind of goes, and we have an image. We can generate some more images, and of course Stable Diffusion 1.5 is a pretty limited model, and so people typically go for better models. But one thing that is good with Stable Diffusion 1.5 is that there is a bunch of LoRa's, which are low rank adaptations, and we will get into that as well. Now let me select a different checkpoint here, and I will just try to get like somewhat encompassing shot of a car. I'm not even sure how to phrase the prompt. I guess we will kind of have to get a bit lucky here, because I want to showcase. Yeah, this is good. I'm gonna turn up the randomizer. I want to showcase the Tencent's geometry generator, which turned out to be surprisingly tricky to install. Now that I have this image here, this is just a part of the workflow that generates an image for me, and this is the part of the workflow that will do the mesh generation together with the textures. And now I'm going to connect this here. This is our seed. I've turned off the randomization, and let's see what is happening here. As we can see, first we have our main base image, and then we do some pre-processing. Now most of this stuff here comes as the documentation to the Hunyuan3DWrapper, and we will install it as well. And basically what's happening here is the base image, whatever it is, I just decided to add this kind of bit to help me battle test it. Now what's happening here is that first we resize the image to the correct dimensions, then we mask out the image itself from the background, like the subject that we want to convert into a 3D model. And this is also done with a deep neural network. Then we have this thing that generates the mesh, which is a separate model. Then there is a phase that is called delighting, which is removing the light data from the image, which is a different model trained by Tencent. Because we need the delighted version so that we can map out the textures that would not have any light information, so that we can light it properly later. Then what's happening next is we kind of reconstructing our normal data from different angles, which is done by multi-view renderer, which is a different model. Then we apply the textures, like we render the delighted model from these shots to get the texture information together with the world positions and the normals. And then there is the baking that's happening. And in the end, the last Tencent Hunyuan3DWrapper node is exporting the mesh. And then the last thing here is to import the model. So we have just done that, and this is our model. If I split the view so that we can see both ComfyUI stuff and the viewport, we can see that this indeed is the mesh of the image we have just generated. Now, there are some caveats. Of course, delighting is not perfect. Textures are not perfect, and the wireframe is crap. Of course, there are some tools that can be used to do retopology automatically and remesh it. They would also not do a great job. I don't know a tool that would do it perfectly. So basically, what we have as of now regarding AI-based mesh workflows is pre-production stage type of assets. It's great if we want to iterate on ideas. It's great for some applications as it is, but if you want to have production ready stuff, it will have to have a lot of polishing done. So typically we have a garbage mesh and we have garbage textures, but we have an overall information, like a bird's eye view of what a model like this of this car would look like, and it is very useful. It is very useful. And so later, you would clean it up, and in ZBrush, you can also do it within Blender because it has sculpting and stuff. But I find ZBrush to be much more comfortable to use when it comes to sculpting. And so usually you would take in the textures, increase the mesh resolution, take in the textures, project the textures to the vertex colors so that you can retain the colors. Then you would clean up your sculpt. Then you would also remesh, and then you would bake the texture data from the high-res 3D sculpt onto a lower res remeshed data, and that's how you would clean it up. So that's an involved process, and it might take some time. It's not something that you'll be able to do in a couple of hours. But this is great. This is a great starting point, and depending on what your end goal is, it might be more or less useful. Now, of course, we can generate any kinds of things, not just cars, basically. And it's also not a censored model as far as I know. So it pretty much gives a lot of creative freedom, and it's free to run, which is amazing. Now, there are also like some other things that we can do here. Here is another workflow, for example. I have some leftover garbage data here from my tests, but basically, the number one thing that you want from AI-based generation is consistency, and it is extremely difficult and borderline impossible to achieve. But the task is usually to find ways to reduce inconsistencies so that you can get better results. Now, you can do those things in several different ways. You can use special, like, you can use control nets, which are uniquely designed to give you more control, and they rely on different data. And you can also use something that is called a LoRa, which is a low rank adaptations, and you can train your own LoRas as well. So basically, if we go to the place called Cvit AI, I hope there is no not safe for work stuff, so the channel doesn't get banned. Yeah, it's pretty decent. So basically, this is one of the places you can download different Gen AI models and different utilities and LoRa's and stuff. Now, typically, conceptually, we have a base model. We have a model. And then we can have it in a form of like, we can have it in different forms. One very popular form, especially like with stable diffusion, is a checkpoint. And a checkpoint is something that within itself has the model. Let me get stylus. So a checkpoint would typically have a model, and it would also have something called a VAE, which stands for a variational encoder, variational autoencoder. And usually, we basically, the way generation works is that we take a model, we plug it into something called a K-sampler, and then let me remove this. We take a model, we plug it into the K-sampler. Then we also get a set of prompts, which, like, it can depend, but if you're working with stable diffusion, you would probably have a positive prompt, and then you probably would have a negative prompt. And positive prompt is something that you want to have, negative prompt is something you don't want to have. And this is basically just pure text, which is gonna get tokenized. And then, so you want to provide this to the K-sampler as well. And then you want to initialize something that is called a latent space. Now, a latent space is kind of, if you have a picture of an apple, then to perform operation and do some feature extraction on it, you would have to encode it into the latent space, which has reduced dimensionality. And the latent space typically has all the different features of what would make an apple, let's say, right? And then you want to extract something out of that latent space, and then you want to extract all of the things that you decided were valuable, and then you kind of take the image back from the latent space, image or whatever data, it doesn't really matter, and then you reconstruct the you kind of reconstruct the result. So typically you would initialize a latent space somehow. Let's say we give it an empty latent space. And so the K-sampler then has some parameters, and it's going to do some calculations and provide you a result, a resulting latent space, which then you will decode using a VAE. It also needs a VAE here, and then we use the variational autoencoder to decode the latent space back into the mode that we are prompting for, and then we would get an image that would result from the prompt. So the general simplest idea is that you give it the model, you give the K-sampler, you give it a VAE, you give it the prompts, and you give it an empty latent space. Then it does the number crunching here, then it decodes the data back, and then we get the image of whatever we asked for. Now, LoRa is something that you can put on top of a model to make it biased toward certain types of results. And here we can see that, for example, let's see something that I used. So this is LoRa. It takes some kind of a base model. For example, in this case, we can see that it takes the base model of Flux 1, the development version, if I am not mistaken. And then it biases the model towards producing better pencil type sketches. So this is something that you would use on top of the model here to get a certain types of results. So this is the basic jargon that we are going to use for the purposes of this video. Now, let me get rid of it and keyboard back. Now, I would like to go through the process of installation before we explore some other things that are possible with the local setup. So I'm gonna go ahead and close Blender. I'm gonna close this stuff. And the first thing that you would need is an isolated Python environment, because everything runs in Python. I am doing everything on a Windows machine. I have thought previously whether I should base everything in WSL, which is a virtual Linux environment, but then I decided to just do it on Windows because it would probably be less problematic. So there are some prerequisites, and first of all, we need to get the Anaconda, which is something that you can download from here. And then I believe in order to download it, you have to actually log in. And then it would look something, let me see. You would, oh my God. Go to returning users, and here you would go towards the like whatever, like we're using Windows. So you just install this stuff. And what's good about it is you can then launch a thing called the Anaconda Navigator, which is basically the biggest problem with Python is its packages, and it's very easy to mess up your environment and completely break everything. So there are ways like virtual environments, and there are like different ways to kind of isolate your local environment from your base environment. And Anaconda is kind of a good way to do it. It depends, of course, on a lot of things, but I think for the purposes of this task, it's gonna fit the role pretty well. We can just and it's very easy with the UI. We can just create a new environment. Let's call it test comfy. Then we will go ahead and select Python 3.12 because I had some bad luck with other versions, so I know for sure that at least on my machine 3.12 works kind of well. So we need to install this, and this is going to start our Python environment. Then we gonna head towards ComfyUI, and I am going to explain what ComfyUI is. Okay, so this is a ComfyUI. It is a node-based interface that allows you to drag and drop different models, different nodes, to basically find, in a very detailed manner, describe which models you want to perform which tasks and which inputs to process how. Basically, this is alternative to writing Python scripts, and because it's an inherently visual task, it is much easier to use a node-based editor for things like this. There are some other types of web-based interfaces, and they are pretty clunky and also not very easy to use, not in a good way. So basically we are going to install this, and then now let's see if this environment is up. Yep, now we can start our conda environment. We can close this, and then we are going to go to like some folder where we would like to keep our AI slop. And let's go here, and what we are going to do is get this repository, and we need to clone it. Of course, you have to have Git on your system as well. So we are going to clone this because I already have a functioning ComfyUI environment. I am going to let's call this test ComfyUI so that I can safely delete it later. So now we're checking out this repository, and there is also a very useful guide on how to install it. I hope my internet doesn't, yeah. So this is the guide. I'm gonna leave all the links in the... This is not the guide. No, this is not the right guide. This is not what we want. This is the guide. Now here, what we want to do is, okay, we have created a virtual environment, we have cloned, now we need to, we have activated our So basically, when you just open up your command line, you can use this to switch and create different environments. We just did it through the UI, and you can use this command to activate whatever environment you want to. Now, then the first thing, like it says that we need to install this stuff. Now, this is the first problem that I have experienced, because the goal was to launch this. The goal was to launch this. This wrapper is basically allows us to run Tencent models within our ComfyUI environment, which was the goal, and it's pretty finicky. It's not very easy to install. And one of the things, like I did, I think, countless different installations, and then I found a way that kind of worked for me. And again, this, I'm not guaranteeing that this will work for you, because whatever can happen will probably happen to someone. And this works for me, and I have repeatedly reproduced it, so this installation should be fine. We're of course relying on some unknown code that is done by some guy, I think, who made a wrapper, and then there might be bugs, there is a bunch of issues, but I hope it will go right. Now we're going to skip this line here, and instead we're going to go to PyTorch, and let's see, we want to go here. Let me actually pin all of this stuff so I can re-add them to the description in the video later on. Let's see. Okay, so this we will use. Okay, so we're going to install PyTorch, and we want to install. Now here's some problems. We want to use Hunyuan3DWrapper, but the PyTorch 2.8 might conflict with some other libraries. Now, when you're picking this stuff, you also need to be sure of which CUDA version you are using. And to do that, you need to, I think it's this command, no, nvidia-smi. So basically you run this command, nvidia-smi, to get to know which CUDA version you are running locally. So mine is 12.6, and so we need to install PyTorch 2.8 Windows environment, pip package manager, Python CUDA 12.6. So we're just going to take this line over here, and we are going to install this stuff, and we also want to install Torch Audio. Now let me spell it properly. Torch Audio. Okay, this seems correct. Let's actually, before I forget and mess things up, I want to go into the test. I misspelled it as well, but that's okay. So let's install these dependencies, and again we are installing it in our virtual conda environment so that we don't pollute. Now this is going to take some time probably, and I'm not sure if this is an entirely good idea to do it on the stream. I think this will need some downloads, and apart from PyTorch, I don't think we will need anything else to download. I won't need stuff to download. You guys will probably need to download stuff, and we will go through what exactly. But you should be prepared to download like maybe even hundreds of gigabytes of crap with different models, because this stuff weighs a lot usually. Now, I will let this run in the background, and while it runs, I will try and launch local conda environment with ComfyUI already installed so that I can show some stuff. And let's see, we go here, we go here, we go here, we start ComfyUI. This is how we're going to be starting it. I forgot to switch my conda environment. I think I misspelled it there as well, so this should work. Seems to be downloading. Okay, we take it, put it on our screen. Okay, let's wait for this to boot up. Now, ComfyUI is a web-based interface, and we can access it in our browser. And this is also the interface that we are going to put inside of Blender. And this is what it looks like. We can add different nodes. For example, something you would do is, let's see, loaders, load checkpoint. So this is like the simplest thing we can do. A checkpoint has a model, clip, and the VAE, the variational autoencoder. And these are the Stable Diffusion 1.5 models. There is also Stable Diffusion XL model, if I'm not mistaken, here, like a checkpoint, if I'm not mistaken. So we are going to use, let's say, a realistic or maybe a Dream Shaper. And the way we can see what these checkpoints do, if we go to Cvit AI and we type in Dream Shaper, see. My internet is dying because I'm streaming and downloading at the same time. This is a horrible idea, but anyway, here in the Dream Shaper checkpoint, we can see that the base model is SD.5, and let's see, is there something else that is vitally important? Yeah, I guess we can look at what it produces. So it's kind of it's a flavor. It's a flavor of art, and we can prompt it in various ways. But what we will need to do here to set up like the basic image generation is we can let's see, clip conditioning. Let's see. I think it should be clip text encode. I think it should be this one. I might be mistaken. Let's see. So usually we have two of this, and one would be a cat, let's say, and the second is a dog. So the first one will be a positive prompt, the second one is a negative prompt. Then we would add a case sampler. Oh, I can't search here. The case sampler, right? And then we connect the model to the case sampler, and then we also connect the positive and negative prompts. So before we, what this node does, it basically encodes the text into a way for the model to understand it. And then we also need to give it an empty image to start with, empty latent image. Yeah, when I was explaining previously, I was mistaken. Like, we do not put the VAE into here. We just put it into the decoder. And then here we can do a decode, and then we give it the decoder. And I think this should be it, unless I am horribly mistaken. Let's see if my memory fails me. And now here is the seed, the steps, CFG, okay. And if we run this stuff, let's see if it works. Yes, we got an image of a cat and not an image of a dog, which is great. Now there are some parameters here inside within the K sampler. We can have the seed. We can have amount of steps we want the K sampler to do, and then we have this CFG value, which I don't remember what it stands for actually. CFG K sampler. Let's double check. Classifier free guidance. And so basically for all the practical purposes, the higher the value is, the more strict it is going to be in following your guidance, and the lower it is, more imaginative it is going to get. And these values, they're all highly, there are also some samplers and some schedulers, which I have not investigated in great detail. I know some stuff about it, but probably not enough stuff to try and to explain how the inner workings are designed. So basically, the idea is that you play with these values for every particular task you have. There is no way to be sure completely which values will produce the great results. There's some general advice. For example, a starting point of CFG 8 is fine. If we want to make it go faster, we could like decrease the steps, but then it would start creating artifacts, and it will look like a worse. Oh, I did not press OK. And then it would look weirder and weirder the lower we go. And if we reduce the CFG values, we would get like completely like imaginative, let's put it that way, result. So basically, this is how the simplest image generation works, and this is how we use ComfyUI. Typically, we would load a model, we would run it through some number cruncher, we would give it latent representation, and then when the number crunch is done, we convert the latent representation back into our mode, and we save it somewhere. So that's the basic idea. Now, for our purposes, this is very nice when it runs in the browser, but I wanted to make it run within Blender because the idea was to do some 3D model generation. And let's see if we, yes, so this installation is complete. And now we are going to continue. I'm gonna pin this tab, and we are going to continue with this. And now we need to install the requirements for the ComfyUI package itself. And we are in the correct environment. Install the requirements. Yeah, hopefully this won't take a lot of time. Okay, so we need this stuff, and then it will allow us to generate models based on inputs within ComfyUI. So that's the first part of the problem. The second part of the problem is that we need a way to install communication with Comfy into Blender. And for this purposes, there is a great add-on that we can use. This is the add-on we are going to install. Now, I already have it installed, but the process is very trivial. Now, what we want to do is get here. And of course, you would need to install Blender, which you can do from here. And I have tested versions 4.0 and 4.5.1 LTS. So I would recommend going higher than 4 and installing the latest. That would be ideal. Let's maybe put it here as well. And then we are installing the add-on itself. And I think the easiest way is to just go here to releases and download this file. And then within Blender, you would go to Edit Preferences, Add-ons, and then Install from Disk. And you would select your zip file, and that would install the add-on. And I have it installed already here. And then we would just need to click on the checkbox to activate it. So that's the add-on part. Let me close this up. Let's see if there is something that I have missed. We install. It is also possible to just git clone it into the script add-ons folder. There is an optional node here, which is called the Easy Bake node. And there is a caveat. Everything is in Chinese. Well, almost everything is in Chinese. So one of the things that can be done here, unless you speak Chinese, is to go to the downloaded add-on folder, and let's see. Oh my god. Go to the downloaded add-on folder and then basically manually translate all the Chinese stuff into English. You can probably use a Copilot to do that in a more efficient way. But then you just save it out and it should work. And so this is the Easy Bake node. It is possible to install it. I found it a bit problematic, like it's a bit clunky. So I'm not sure, and the results are not very good as well. So I'm not sure if I will end up ever using it. And then I don't need the Linux instructions for this. And then the usage. Okay. Okay, so these are the, we don't need this. This. Okay, so this is all good. So basically this is very simple. You just install the add-on with a zip file and you are good to go. Let's see. We have installed, let me close this stuff. Okay, so we just have installed the dependencies, and then we can start the ComfyUI, which is pretty trivial. We just do python main.py. And so we are going to start our environment now. Let's leave this. Close this. Let's do the first run. Okay, we are going to open it up. There's some cached browser data, we don't need it. Okay, so this is our basic ComfyUI. Now, one thing that is very useful to have when you're running ComfyUI is installing the ComfyUI manager, which allows you, oh my god, I'm not a robot, which allows you to manage add-ons within the web interface. Like not all of them, but most of them, which is a very nice feature. So we are going here and in this repo, it's pretty straightforward. We just clone the repository into the close ComfyUI. We go to the folder named custom nodes and we just clone the repository here. Now we are going to restart ComfyUI after that, and it's going to fetch all the dependencies needed to run the manager add-on. So we're gonna go back and we're going to run python main.py. It's gonna install some stuff. Okay, while it's doing that, we are done here. I'm gonna pin this as well. Now, ComfyUI. Okay, so now we are here. Now we want to install the ComfyUI-wrapper for Hunyuan3D. And this is where it gets like a bit more problematic, because we will have to make sure that we have Visual Studio C++ compiler installed on our system, and to do that we need to go here and download this stuff. Gonna pin the tab as well. So we need basically to install Visual Studio, and within the, let's see if I can get away with running the installer and not installing it, but showing the options. Okay. Okay, so yeah, basically this is what you would like to have installed: Visual Studio build tools. And can I see? Yeah, so this should be enough, because the main thing you want is MSVC toolchain that would allow you to compile C++, and because that is needed to do this step, basically. But now that you have the thing installed, we can go and check the manager, because it should have been installed. Now we get this manager tab, and this button, when you press it, opens up this window, which allows you to install missing nodes whenever you need them. And it also allows you to just browse through all the available nodes and install and update and manage them, which is very useful. Now we're going to get here in a bit. Next thing we are doing, like there are some instructions here, because we want to download the actual models, and they're pretty chunky. And like if we go to Hugging Face, which is basically a place where a bunch of models are stored for public access, this is what we'll need to download. And let's see how. It's 4.6 gigs. I'm not gonna download it, but you get the idea. And we have no. I don't think we need this one actually. Sorry, excuse me. This is the main model. This is the one converted to safe instance. We need this. We need to download this. And if we go to files and versions, this is what we need. This model, and then you take this file and you put it into. Let us see where we put it. Test ComfyUI. So this is the main folder. We would go to the models and the fusion models, and we put them here. We put this file here. And however, before I continue with the next step, because I already have like actually several ComfyUI installations, but I do not want to kind of copy over all of the different models. There is a way in your ComfyUI installation to kind of do a shortcut, like a symlink to a different folder. So let's see. This is my installation through the stability matrix, which I've toyed with in the past, and then I have my ComfyUI installation here, and I have a bunch of checkpoints, a bunch of models, etc., etc., all of them installed here. And so what you can do, if you want to store your models in a separate place, there is a way to do it, and I'm going to demonstrate it. There is a file called extra model paths.yaml.example, and we are going to open it up, and basically it shows us how to do the mappings for different web interfaces like A111, etc., etc., because you can share all of these models between different user interfaces like ComfyUI. Now, I already have my my file. I'm going to copy it from here. So basically the idea is you take this file, you copy it and rename it, removing the .example in the end. And so this is the file I used. And we are going to go here, copy it over. This is what it looks like. So I basically just mapped everything to this folder with my stability matrix installation, but it doesn't matter. Like, you don't need to do it. I am just doing it to not copy over stuff, because ideally, if this is your clean first installation, you can put all of your different models into the corresponding folders as per instructions. So this is this part, and now we want to take this repository. We are going to stop ComfyUI. We're going to go to custom nodes, and we are going to clone the repository like so. Okay, now we go into this folder. Let's see what we need to do here. First, we need to install the requirements. So let's do that. Okay. And then there will be this step. So there is a caveat. If you have Python 3.12 and if you have Torch 2.6.0 plus CUDA 1 to 6, you can just use the wheel they are providing in the repository. But since I am using Torch 2.8, I cannot use this two pre-built wheels. So that is why I have to run the script that would do all of the compilation on my system, and that is why we need the MSVC and Visual Studio build tools for C++. Now here we have installed this stuff. Let me see. So there are two parts that we need to build. First is a rasterizer, and the second is the differentiable render. Yeah. So this is only needed if you want your 3D mesh generator to kind of have textures. You don't need to have that. If you just are interested in a model, this step you can obviously skip. And okay, let's go into this folder, custom rasterizer, and then we are going to just keep going along with the instructions. So this will start building, and then we are going to do this stuff. Okay. Now, what else is left? We will have some missing custom nodes. But we will install them with the manager. And we will also need to download some models, I assume. So for the purposes of this video, I'm just going to use a simple checkpoint model, like a Dream Shaper. And then we will see, okay. Extracting, removing, creating. So this seems like it went okay. Now we need to go to differentiable renderer, and then we build it. Okay, now we can return and let's relaunch ComfyUI. Now, next thing, to test if this actually works, we will need to open up a workflow. Now, a workflow is a JSON file which has all of the node structure for your particular workflow, and there is a workflow that we can test it against. Let's see. This is the workflow. Let's see if this is enough or no. We need to see where I found that workflow file, because it's pretty important. So usually, like a common way to do it is to have like a workflow.png which is an image, and the metadata of the image allows this image to be imported directly into the ComfyUI web interface. So I am now trying to find where I found that workflow image. Not only for people who are watching this, but also for the future me. It might be useful. ComfyUI-wrapper. There. Let's see. This might be a bit interesting to get. Is there a workflow in here, maybe, in the repository? Yes. Yes. Yeah, I'm so stupid. So this is the example workflow that we want. Okay, so this is the file, and we are going to just drag and drop it. And so several things happened. We can see that there are some missing nodes. And the good thing with this stuff is that we can open the node manager, not this one, install missing custom nodes. So it says that we are missing this. So we're just going to install. And then we need to restart. Yes, this is going to restart our server. And it's also going to perform the installation of the nodes. And it's like the reason why it's good to isolate the Python environment is because like you can install a node and then it has like some transitive dependency conflicts and stuff, and everything just gets screwed. So it's good to not pollute your system. Okay. Okay, now we can refresh. Hopefully we don't get that error. So this is great. We can see the workflow has actually loaded. And now, let's see. So this is the example image. We're going to go through this stuff. Let us see if this works. So as far as I remember, the default workflow doesn't work out of the box and it causes some issues. Yes. And the thing here is, first of all, if we're just to run it in our browser first before going over to Blender, we need to make sure we're using this Hunyuan3D FP16 safe tensors, because by default the workflow assumes a different directory. So we just need to refresh and pick what's available in the list. Next thing that we need to do, all of these nodes for some reason wired to use the mesh, whereas the outputs are trimeshes. So I found that just by fixing this and wiring them a bit differently to use trimeshes fixes this problem. And we can see also here, I'm not sure why exactly the workflow is not updated. There is also a trimesh here. Okay, let's run it again and see what is happening. Okay, so I'm gonna pause this here. So basically, what's happening is, the first time you run this generation process, there is a script within the Hunyuan that basically starts to download all the missing Hunyuan models. And these are the models. Like basically, if you go to ComfyUI, test ComfyUI models, if you go into the diffusers, it will start downloading all the necessary stuff into this folder. Now, because I already have them I am going to keep it continuously. Okay, let's refresh. Open in Python. Okay. We are, let's do this. Yes. And then, yes, let's do this. Okay. Okay. So what I'm going to do is, I'm not sure whether the linking works. I think the wrapper needs to have actual files in here, and I don't think like symlinking works in this case. So I am going to copy over this folder so that we can continue. It would do nothing, like this step is not necessary when you're just installing it from scratch. I just don't want to download tens of gigabytes. And let's go here, let's go to models and diffusers. So this is what I want. So this will make sure that the download script kind of skips, and then it gets to the actual generation. It just happens on the first run. Okay, now let's do test confy. Yes, conda activate test confy. No, is it UI? Test confy, yes. Okay, so we have changed the environment. Let's do python main.py. And let's open. Okay, everything seems good. Let's start the process. As we can see, we have the percentages here now. And this is good. Okay. Okay, so something is happening. So let's break this down. We have the image, which is the default image. And then it gets resized. The background is being removed, and we get a mask. And then let's see. Oh, we missed an input. So we are going to fix that real quick. It should also be trimesh. And let's run it again. Okay, so then the base mesh is being generated like so. And of course, I restarted the process, so it's going to do this again. Let's see, I think it did not. So let's see if this works. Oh no, it is still running. Okay, all good. So after the mesh has been generated, it does some delighting, remove the light from the image, does the multi-view sampling to get the normal and position data. Then it would make a rendering from all of these camera angles. And it is possible here to also adjust the camera config with the distances and different angles. And then let's see what is happening. Okay, so now the rendering has been done. Then there is a unwrapper and UV unwrapper and baker, and we get this end result. So basically, this is how we run this stuff within browser, within ComfyUI, which is the reason I kind of decided to try how to do all of this stuff. Now, this is not the end though, because I want to do this thing from Blender, and for that purpose, we are now going to open up Blender 4.5. And I am just going to load up the previous workflow file I had, because if we have our ComfyUI add-on, ComfyUI node editor loaded up, here we can, let's see, we can specify a port in which we are running ComfyUI on. So the default port is 8188. So we are going to do the remote server, because then it's going to connect to the Python application via this port and this address. And I don't think we really need to do anything else here. Now what this does, it creates, let me split the view. It creates this ComfyUI node. And within this node, we can connect to the running server. This means it has connected. And then we can start assembling nodes. And now what we should be seeing here, aside from the general nodes, is the Hunyuan3DWrapper option, because this means that now Blender's node, a custom node add-on, sees whatever we have installed inside of the ComfyUI. Now, this is the workflow that I have showcased in the beginning. Turn this off. That I have showcased in the beginning. And this workflow needs, I think, it just needs a Dreamshaper checkpoint to be downloaded from CVIT.ai and placed into the checkpoints folder here. Now, I obviously don't have it here. I have it in a separate place, but it's symlinked, so it's all good. No, I have it actually in here. Packages, ComfyUI, models, checkpoints. So the Dreamshaper is here, or you can use like whatever checkpoint you want from Stable Diffusion 1.5. So I use that to generate this stuff here. And then I basically copied over all of the nodes, since they are all available. And I can save this Blender file if it's interesting and publish it as well, so that it's easier. And then in the end, there is there are some nodes that are unique to this add-on, which allow you to do Blender input-output. So this allows you to import the model into the scene once it has been generated. And we need to, like, one caveat, we need to export, use the Hunyuan 3D export mesh node and set it to GLB before we can import it, because I don't think OBJ or FBX worked for this node. The Blender add-on is a bit janky, so it might take a bit of trial and error to make it actually work. Like, one thing that happens right now is like if I connect to ComfyUI, this node disappears, and it's a reported issue in the repository. And the suggestion is, I think if we go here, I even commented on one of the issue. No, it's not ComfyUI manager. So there are some issues here. Extension can fetch the. I don't think this is that one. I think this was the issue probably. This one. Yeah, so basically it seems like for some Blender versions, probably for most of them, the add-on doesn't is not able to fetch the Blender nodes, the Blender specific nodes. So these nodes are used to communicate with the Blender, and they're not visible in the web interface. It's just purely for the Blender side. And someone said that once they like changed the port to a different port number, and then did some like I'm not sure how I'm not sure if that is what is causing it, just playing with the port numbers, because it seems like on a default port it doesn't work. But I think it's some clunkiness in the add-on itself. So this thing is a bit problematic. It might be a bit problematic, and let's see if I can somehow fix it. Okay. Okay. Let's try this again. No, it doesn't see the node, which is interesting. Let's see, maybe the script is doing some custom node installation, and this sometimes fails. Projects comfy, and if we do custom nodes, so there is Blender IO stuff here, and let's see if there is a Blender IO stuff inside of our current. No, so there is no Blender IO, and it seems like the installation should have happened via the script, but it did not happen. Let's see, maybe we missed some steps. Oh, we also no, this is not needed for this. Set the ComfyUI. Okay, so maybe this is how it works. If we change to local server and we pick the ComfyUI path, maybe this is maybe that is what it's using to install the let's see. Project test ComfyUI. This is our ComfyUI path. And does it need to have access to Python? Let's see where the Python is. Conda. This is what we need. Okay. Maybe first we try to launch it with via a local server. Maybe that's what's making it to. Yes. Okay. So now I can see the Blender IO here. And then I think. Come on. Close. Yeah, I think so. That might be the missing step. Now we can probably change to this. Test. Okay, now we run Comfy. And yes, we are connected and we have our Blender specific nodes, which we have here. So yes, I'm very glad I made this video because this was an unintuitive step that I did by an accident. But now that I kind of think about it, I understand why it did not work. It should probably be documented. And maybe I will make a PR later if I'm not too lazy to add it, ask the author, add it into the documentation. But basically, we have our mesh generator running against our newly installed ComfyUI setup. And again, I just went through this workflow available from their repo. I fixed up all of the conflicts with the trimesh versus mesh, and then I just used the same nodes to do the logic, and everything else is intact except the save model, which allows us to import the thing into the scene. Let's try to do something random. A car is good, but maybe let's try compositor. Oh my god, where is this? Okay, render. No, I don't want the renderer. It's been an hour and a half already. I'm kind of cooked. So maybe I will do the rest of the control nets and the additional render like data like scribbles and canny nets and normals and position maps and depth maps to control the output of the generation in a separate video because I'm kind of getting tired. And let's see. So what I usually do is I detach this part from the rest of the system so that I can just experiment with the prompts to get some fast images. Let's see what can we do. I don't know, like maybe a head sculpt. A head sculpt white background, and it's better to make it on white background because it's kind of easier to separate. Let's turn on the randomness and execute the node tree. Let's see what it comes up with. Okay, this is an alternatively beautiful face. Let's try again. Okay, now let's take this and make something out of it. So let me see if everything is connected. Yep. And execute node tree. Okay, so now it's going through the process and we should get a sculpt of the head. So the masking worked fine. Okay, the lighting, it kind of sucks. I have to admit, the lighting is kind of sucks. It's not very useful for this image. Well, that's what you get with AI. It's mostly slope. Okay, let's see what's happening here. Removed degenerate faces. Okay, so we have 830,000 faces, and it's going to get optimized down to 50,000 faces. And so the controls for that are here in Hy3D post-process mesh. It's not recommended to set it to a number more than 50,000. And then by adjusting the octree resolution, we can increase or decrease the quality. There are also steps which we can play with, and there is also the seed for the Hy3D generate mesh. Now let's see what this looks like. And we have the model of our face. And this seems like something. It's not bad at all for this much time. And we can also prompt for different things. We can prompt for buildings. We can prompt for full body characters. Let's see, male character, white background. Let's see what this would spit out. Maybe a full body shot. Okay. Let's try to put this through and see what happens. Oh no, I turned on the randomness. I lost the seed. Let me cancel this. This is such a weird image. Oh, what the hell is this? Oh, I lost the seed. It's such a pity. That was a... Oh. And I forgot to disconnect it from the generator. Okay, let's see some alternatives. I want a full body head to toe. Yeah, this seems interesting. Let's reconnect. And let's run it. Okay, it seemed to have isolated it correctly. See what's happening. Okay. Okay, here's our guy. Let's see what it looks like. I'm gonna collapse this. We don't really care. Oh my god. Close area. Yeah, this is not bad at all. This is not bad at all. The mesh, of course, sucks, but it's irrelevant. This is pretty good result for a minute of generation. Well, yeah, and then you of course can like combine all of these assets. You can get into the sculpt mode. You can do whatever. This is an interesting pre-production kind of exploration phase tool. Yeah, I think you can do a lot of things with it. It's kind of nice, especially like if you're maybe into like stills. For stills, it is very good, because in a in the next video, if I ever get the energy to do it, I would also like to showcase the other side of it, which is basically taking this as an input with the depth maps, with all of the data you can get from a 3D scene, and then pipe it into into a model through control nets that would allow you to have a finer control over the end results. And if I get energy, I will showcase that too. It is possible to do through Blender directly. I did not find it particularly comfortable to use though. I think the best way is probably to run batch rendering with all of the channels exported, and then you would import that batch into the ComfyUI and process it from there. And maybe even, I think it would be even a better idea just to write a Python script to handle that kind of batching logic, unless there are like nodes or tools already to do that. But yeah, there are lots of possibilities. I would say my verdict is it's still pretty much AI slop, and I fail to see how to use it efficiently in a way that would save you a lot of time. I would probably say that locally hosted, or maybe even like tools hosted in the cloud, they would probably give you maybe a boost of 5%. Like 95% of the work, like you will still have to do yourself if you want to get, reasonable results. Unless you have a very niche sort of application where you don't need a lot of consistency or a lot of details. Like if you would use these models, like, I don't know, from afar and without animations, like it's not very good for production, and it would save you some time, but probably not a lot. Because I was initially considering using, like investigating the AI landscape for generative art to see if I can easily make like an animated movie, and that is not easy at all. In fact, I think it is more tricky to do something well than if you were just doing it on your own. And I think if you know your tools well, you will currently be more efficient with using AI just in pre-production step, or maybe in post-production in a very isolated scenarios. But yeah, unfortunately, I do not think this is something extremely useful. It is somewhat useful, and it's good to have this in your toolbox. But it's not gonna solve all of your problems. So that is my verdict, and of course I'm very much interested, like both like in neural nets, both from programming perspective and from artistic perspective. So I will definitely keep doing stuff every now and then, and we'll see. Maybe something interesting comes out of it. I will do next upload fairly soon with some of the newest developments regarding the game I'm currently working on. I still have some stuff to do there as well. I really want to finish it. I'm kind of getting a bit burnt out. And I do not want that to happen. So I will do what I can and hopefully continue with other projects in the future. Thank you so much for joining me, and I will see you guys next time.